Hello, oh, buongiorno.
Hi, nice to meet you.
Nice to meet you. Do you speak English, Italian?
Yeah, I'm
Ok,
Italian.
ciao. Ah, bene, bene.
Anche te?
Sì, sono italiano.
Ah, grande, grande. Ci siamo già visti alla
Ah,
HubeCon.
ci siamo visti alla conferenza, ok.
Sì, sì, sì. So se ricordi, siamo quei disgraziati di EDB, quelli dell'operatore Cloud Native PG.
Mhm.
Ciao. Ciao.
Ciao.
Buongiorno, ciao. Vedete CockroachDB e Yugabyte, quel tipo di database, diciamo nuova generazione, li vedete come vostri concorrenti o no?
Ma no, no, secondo me hanno un altro, hanno pro e contro differenti, sai. Sono
No, ok.
degli use case per i quali sono molto appropriati, altri dove invece Postgres vince. Io almeno non li sento come concorrenti.
Ho capito. Ok.
Oh,
Ciao.
hi
Ciao.
everyone. Hi. Hello.
I think we have to switch back to English.
Yeah.
Yeah.
Hi. Hi, Shin.
Hello.
Hello.
Uh, all right, so I'm just keying on the channel. Tell folks we're getting started. Just wait for a few minutes. Usually we start 5 minutes past the hour. So Elena, you have a slides that you can share. You can add to the doc.
Mm-hmm. Yeah.
Maybe we have to make the presentation public.
Yeah.
Yeah, you can do that later. It's fine.
Yeah, we'll make it public and add it to the agenda. And
Yeah. think we can get started now.
Okay, so I'm gonna share my screen.
Okay.
Turn on my camera. Hello. Share. All right, can you see my screen?
Yes.
Yeah. All right, so hi everyone, I'm Gabriele Fedi and I'm an engineer at EDB. And today, along with my two colleagues, Matteo Biagietti and Gabriele Quaresima, we're going to talk about how we managed to leverage the Volume Snapshot Kubernetes APIs and Cloud Native PG to implement snapshot backups in our EDB Big Animal product, which is the database as a service product provided by EDB. Right, so we're gonna have a brief introduction about Postgres and how it performs at storage level. I'm not gonna go through all the features provided by Postgres, but I'll mainly focus on the storage operations. Then Gabriele Quaresima is going to talk about Cloud Native PG and how it implemented the snapshot backups with the Volume Snapshot APIs. And then we're going to talk a bit about some benchmarks and results that we have faced on the main CSP providers that Big Animal supports, which are AWS, Azure, and GCP. So yeah, let's start with Postgres. So Postgres is one of the most popular relational databases that are present today on the market. As it is a database, it's of course a stateful application. And so it has to manage a storage. So let's see how Postgres manages the storage. In its most simple architecture, you will have the Postgres processes running, performing write and read operation on a single directory, also known as PG data. And you have this PG data directory being mounted on a single disk. In a more complex architecture, you can have multiple volumes. So you can have one volumes for PG data, one for WAL files. I will introduce also what WAL files are in a bit. And then for table spaces. So basically, table spaces are a feature of Postgres where you can tell Postgres to store table contents on a different directory rather than the PG data one. But also in this architecture, we have all these directories being mounted on the same disk. You can also have an even more complex architecture where these directories are mounted on different volumes and disks. So yeah, I want to mention also what write-ahead log files are. So WAL files are basically a set of files produced by Postgres for tracking changes made to the database cluster. These WAL files have a fixed maximum number, maximum size. So every time that size is reached, another WAL file is created by Postgres. These WAL files are archived periodically, And one important thing is that these WAL files are incremental, and they can be replied individually during recovery. So for example, they also use for important features like point-in-time recovery, or for achieving consistency in a not consistent backup. So let's talk about what backups and restore are. So of course, the backup and restore capability, the backup and restore feature is the capability of restoring the state of a certain database cluster on a new database cluster on a given point in time. So we can have two different kind of backups in Postgres. We can have the logical one and the physical one. The logical one is basically a set of SQL instructions that can be applied sequentially to restore the database. So this backup is basically composed by one or more SQL files that can be applied on a new database to be restored. One important thing to mention is that the logical backups are always consistent. On the other hand, the physical backups are file system representation of the content of the data directory used by Postgres when the backup is taken. There are mainly two different techniques for implementing physical backups. One is by making a file system copy of the data directories, and the other one is by taking a consistent snapshot of the directories used by Postgres. So this picture represents a logical backup. So one important thing to notice is that this type of backup is performed at Postgres process level. So you need to have your Postgres process up and running. So by making a pgdump of the database, you end up having a SQL file or multiple SQL files that can be restored on a new cluster, on a new database cluster, which is the one on the right-hand side. For physical backups instead, as I was saying, we can have two different kinds of backups. One is the file system copy, and the other one is by taking the snapshot. Snapshot of the volume that your database directories are using. And for this kind of backups, the physical ones, one important thing to mention is that when they are done online, meaning that on a database cluster that is being used by applications, those backups are not consistent. So you might have to reply some WALs files to achieve consistency and to have your database being recovered properly. So this picture represents the two different kind of physical backups. So one important thing to notice here is that these backups are performed at storage level, so not at Postgres process level. So for the file system copy, you can make a tarball of your data directories and then untar that archive on a new storage. And for the snapshot techniques, you need to take a disk snapshot of the volumes used by your database cluster. if of course your underlying storage needs to have the capability of performing the snapshot. And in case of multiple directory being used, it has to have the capabilities of taking consistent snapshot of those different directories. To perform a restore from a disk snapshot, you just have to provision a new disk from the snapshots, and that disk will be a representation one by one of the old disk, and so you can perform the restore this way. Of course, both techniques have pros and cons. For example, taking a file system copy might be more simple and flexible and cost effective, meaning that it can be cheaper. But it might be more slow for large database and can impact database performances. On the other hand, one of the main advantages of these snapshot backups are the recovery time, because provisioning disk from a snapshot might be more faster than copying files when copying back files when the database is very large. So you might want to use this feature for very large databases. In terms of cons, snapshots might be more expensive comparing to file system copy backups that could be stored on object storage like S3 buckets, for example. They might have vendor lock-in, so migrating these backups from a provider to another one might be harder. And of course, your storage need to have the capability of performing this operation, the snapshot operation. So now I think, yeah, Gabriele is going to take the stage for talking about Cloud-Native PG and how it works with snapshots.
Okay, here we are. So yeah, after discussing a bit how Postgres works around backups and recovery, I'm starting to move through Kubernetes. So we will talk a bit about the Cloud-Native PG. That is a Kubernetes operator that basically covers all the life cycle of a PostgreSQL database. The role of this operator is to simulate what a human DBA will do with Postgres. So, but yeah, in an automated way, relying on the Kubernetes operator extension. So yeah, we are going to take a look into it. We have in the call two of the main minds behind the Cloud-Native PG, that are Gabriele Bartolini and Leonardo. And also me, Gabriele, and Matteo are involved in the support and in some contributions there. So we are very proud of this product. Let's go to the next slide, please. So Cloud-Native PG has a long list of features and behaviors. It has been released open source on May 2022 it has been given to the community by ETP, and we continue to work on it, and there is an active community also on Slack, but yeah, also on the public repo on GitHub, counting more than 4,000 stars. And yeah, let's take a look on some features. So yeah, self-healing capability, for example, we pushed what we can into Kubernetes, so it became a natural choice to rely on Kubernetes for such an operation like this. And also the scale up and down well fit with Kubernetes features, and the declarative management, and yeah, to basically rely on manifest to declare what you want. And also you can plan to your backup strategy if via object store, or if you want to rely on the volume snapshot, for example. And that is the what are we going to explore closely in the next slide. The full list is there is a link there is pointing to the documentation of the documentation of the repo of the Cloud-Native PG. So please, next slide. Yeah, thank you. So yeah, the first kind of backup that has been supported, that it is the object store one. So so basically, Cloud-Native PG support this kind of backup. And with the object store based backup, you can perform the hot backup, also known as the online backup, and just it. And it requires a whole archive and doesn't support incremental or differential copy. With volume snapshot, you can have or hot or cold backup. So also the offline backup is supported. Do not require the whole archive, but yeah, it is recommended. And also, if the storage class support it, you can add you can use the incremental or differential copy. For example, there is an Azure storage class that in which you can specify in the parameter list a key value incremental true, so that you are telling the storage class you want to use the incremental copy. And if you go to the next slide, we have all the differences resumed in a table that well fit and resume all we have just said. And again, there is another link to the documentation that is going also in details, for example, with the point-in-time recovery feature and so on. So next slide, please. So yeah, Cloud-Native PG rely on the scheduled backup CRD or on an on-demand backup CRD, so that basically you ask for backups. And also Cloud-Native PG rely on a PostgreSQL feature when performing the backups. So the backup from a standby. So the easiest architecture of Cloud-Native PG is one master and two standby. And you can perform the backup also from the standby. Next slide. In order to support the online backups, we need the wall, the write-ahead logs that Gabriele showed us before. And we rely on a tool, on Barman, in particular on the Barman Cloud API, to orchestrate this backup infrastructure, and to basically ask to ask for walls and know how this infrastructure is built. So, for example, you can provide the SRE address, or you can provide access keys, or which kind of compression and so on. So basically, if you go to the next slide, we can see an example on the of backup stanza inside the manifest of the cluster of the kind cluster stands for the Postgres cluster of Cloud-Native PG. So inside the spec, we have this backup with a Barman object store stance, in which you can specify the destination path, for example, the S3 in this example. Then the credential you need, or the compression, the retention policy. So basically how many days you want the backup stand there before deleting, and let's say having just the most recent ones, only the latest 30 days of backups. Yep, go to the next slide. That was an example of backup relying on object store, but we are here to talk about Bulu Snapshot. Oh, Raffaele, there is a question.
Yeah, thank you. I have a question.
I don't know if it is on this slide or how many slides before that. I just noticed it.
It's fine. I have this question I would like to ask before I have to drop. I apologize, but I have to drop at 30. So I talk now with several customers that are looking for backup solutions, right? And what they're looking for is a single tool that can take backup for any workload, backups for any workload. The main use case is virtual machines, but I think it's irrelevant. My question is, why would I choose a tool that does a backup only for a specific workload, like in this case, only for EDB? Was that clear?
Yeah.
Okay.
Can
No,
you
if
please
you have an
repeat
answer,
that, Rafa?
Yeah.
Can you please repeat that?
So I talk to many customers now that are looking for backup and restore solutions for workloads in Kubernetes, right? And they look for something that can work with any workload,
Yeah.
mostly virtual machines, right? But any workload, right? That shouldn't matter.
Okay.
So why
Yeah.
would I choose a
Got it.
tool that can only work with a specific workload? Like, obviously, if I go that way, then any workload, I have to pick their dedicated tool, and it's a lot of a cognitive load, right? So can you explain your point of
If you
view?
don't mind, I can.
Yeah.
I can talk about that. I mean, it's about data protection at two different layers. One is at the Kubernetes layer. So, for example, not at the moment Cloud-Native PG, but we are providing as a fork of EDB, so it's not entirely related to this presentation, a transparent way to, for example, integrate with Velero or ADP for OpenShift, Kasten, and so on. Okay. So essentially, we work with these tools at the Kubernetes level to transparently back up all the necessary resources. Okay.
Mm-hmm.
If you want, you can search for it. It's called external backup adapter as a functionality. But with Cloud-Native PG, essentially, the idea is to provide DBAs, especially the possibility to run point-in-time recovery with the database. So normally, DBAs could be responsible for managing databases, and they might need to provide a point-in-time recovery at a transaction level. So essentially, the previous one operates at the entire cluster level, okay? And also provides you with a way to restore with a larger RPO any resource, okay?
No, that's not entirely true. You can work at a cluster level, you can work on namespace level, you can work on an individual workload level. They are configurable.
Yeah, but I mean, in terms of the database needs to be consistent.
Mm-hmm.
Okay, so there's the write ahead log. So unless you have a way to work with the Kubernetes level backup tool in terms of recovery to restore that, and for example, there's Canister. I know Canister works with the operator. That's how, this happens at that level. But at the same time, you can restore for a specific cluster. So by relying on the PostgreSQL level capabilities. So that's the main advantage of having both, which are used in different use cases, primarily one on the infrastructure level and the other one on the database or even application layer. Because the idea here is to allow development teams to own a specific microservice database. So that ideally they're independent in the whole life cycle of their application database. So it's providing basically flexibility to perform these operations. We don't require these, okay? And I think the work that we're doing in terms of consistency with volume snapshots will also facilitate this integration even more. You just need to create a volume snapshot resource, and that's it. So I don't know if that answer, but it's to provide flexibility, two different ways to back up and restore, and provide the options to the use base essentially, without losing on the point in time recovery flexibility that Postgres provides natively.
So if I understand correctly, there is your operator, your backup functionality is more consistent than the other ones. That would be the case.
Yeah, Postgres is designed to work with, especially if you have multiple volumes, with the inconsistency on the physical base backup. That's how it's called. Okay. So, but to do that, you need write ahead log files, because from the time you begin to take a backup to the time you finish, it might take hours even, okay, if not days. I mean, in the past we've had people taking days to back up. So the database changes.
Use snapshots. Snapshots are instantaneous.
Yeah, and that's what our support does. And that's what basically Leonardo has been working with the team in the past. So we provide also a way for object stores. And yeah, Leo, go ahead. Yeah, sorry.
Was just maybe a bit clarifying. The database may be distributed across many volumes.
Yeah.
And yes, snapshots are instantaneous, totally, but they are not consistent across all the set of volumes of which a database is composed. To do that, we really need volume group snapshots.
Okay, so that's the point. That's where this approach is superior than the other one.
Exactly. With volume group snapshots, in theory, you could get a consistent backup across all the volumes.
Okay.
But still, in my opinion, to be 100% sure, you still need your world archiving to work correctly.
Yeah.
Because in my experience, that might still fail.
But also for point in time.
Yeah.
Recovery. Volume snapshot is a start, but is a consistent start. And also, I think the other one is the backup from the standby. So what we do is shut down. We have two ways, hot and cold. The cold shuts down the standby and takes snapshots of all the volumes, and that's by definition consistent. And the hot one also has the necessary WAL files to restart and be consistent. So we have a few options.
Okay, so it does more orchestration knowing the actual workload.
Yeah, absolutely. That's the point.
Yeah. Okay.
And you can achieve that by configuring your backup tool if you want that. But it's, in my opinion, it's better to be as near as possible to their workload, at least in this case.
Okay. I will look into that bridge that you guys are developing between these solutions and your operator. Because I think if you can, let's say, use Kasten, but when you do a backup of a Postgres database, Kasten actually delegates to your operator. I think that would be the best of the two worlds. But customers will be looking for a single tool.
Exactly. And this is what
Yeah.
we have with
Yeah.
Yeah,
Cast
that's what we've done with them.
and
Okay.
with Vero too. Yeah.
Okay. Thank you very much. I apologize. I have to drop now.
Thank you, Raffaele.
Thank
Should you have any
Thanks.
insights, just ask.
Okay, so going back to the slides, and thanks for the question. Okay, Bolu snapshot on Cloud Native PG cluster can be performed only if the storage class support volume snapshot. So most recent classes in main provider do this, but if you're using a very old storage class or some exoteric ones, who knows? So yeah, you should be sure of this. Next slide, please. So yeah, here we have an example of a stanza in which we are configuring a backup via volume snapshot. So we specify in the spec the storage class of the storage and its size, same for the whole storage. And then we have the backup declaring that is a volume snapshot one. You can set online to false, so you are taking a cold backup. Otherwise, the default is a not backup. And then again, you need to specify here the class name, so the volume snapshot class name, and that's it. So yeah, it's very declarative, and yeah. Okay, next slide. So yeah, after performing the backup, we are interested on the other phase of the moon. So the recovery. The recovery, we cannot recover using on top of an existing cluster, but basically recovery is a way to bootstrap a new Postgres cluster from a physical backup. So that is a way to bootstrap a cluster at the end. So you can bootstrap a cluster by initdb, by a PG-based backup, or recovering a backup. That's what are we focusing now. So next slide, please. This is an example of recovery from an object store. So we specify as bootstrap method the recovery and the source, the name of the source cluster. That is, this case is cluster backup. So our new cluster will be the cluster restore, and the old cluster is the cluster backup. And we also need to specify all the details we need for the object store. So in the external clusters section, we have this cluster backup, and again, all the details. Here, the example is on Azure, so we have the storage account, destination path, the credentials, and in this case, there is also the parallel job for the wall that are 8. Yeah, this is the example of the recovery from an object store. We have also an example in the next slide of recovery from volume snapshot backup. So go to the next slide. And in here, in the bootstrap recovery section, you can specify that you're using the volume snapshot. And we need just to add the snapshot name. So it's very, very easy and straightforward. Yeah, I guess I'm done with my presentation, and I'm going to to let Matteo speak about the use case in Big Animal. So Big Animal rely on the core rely on a closed source of the Cloud Native PG, but basically they are very, very similar, if not equal, in most of the code. So yeah, Matteo, tell us what happens in Big Animal.
Thanks,
Excuse me.
Gabriele.
Excuse me, before moving on, I have one question.
Yeah.
Leonardo, you mentioned that you do have integration with Custom and Velaros. I'm just wondering how that work? How would that work? You did mention that way, or maybe Gabriel, I think one of you mentioned that.
If you like, I can answer, Gabriel.
Yeah, it's better. I don't know a lot of details there, but yeah.
I'm definitely not an expert too, but if you already have a Velero infrastructure in your cluster, the same happens with Custom. You can configure our operator to integrate with it, and the operator will annotate the pods with a set of commands they are basically hooks that are executed before the backup and after. And this set of commands will basically enable the backup mode of Postgres, which will do a lot of fine tunings to be sure that walls are not recycled, to be sure that the backup is as consistent as possible. And yes, this is how it works. These backups are in turn implemented by our operator, which is inside the workload pod tool. So it is able to coordinate everything. I don't know if this answers your question, Shin.
Yeah, sure. Thanks. Yeah, you please go ahead with the next topic.
Okay. Matteo, it's up to you.
Yeah, so let's start talking about Big Animal. Big Animal is a database as a service tool that is part of a data platform called EDB Postgres AI, and is a database as a service built on top of the Cloud Native PG operator. So it uses all the features exposed by the operator, and could work in a fully managed environment or in hybrid environment. This means fully managed in the Kubernetes cluster is hosted by ADB. In the hybrid mode, we can create the Postgres cluster inside the Kubernetes environment of the customer, and also support Azure, Google, and Amazon as a vendor. Next slide, please. So this is just a sample of the UI. You can see the page of the Postgres cluster. And next slide, please. When you create the Postgres cluster, you can specify the type. And if we want to deploy inside the cloud service, mean fully managed or inside the cloud account of the customer, you can specify the cloud provider and the region where you want to deploy the cluster, the Postgres cluster, sorry. Next slide, please. And also you can easily define the storage layer of the Postgres cluster, where to store the data and the Vault Archive logs, which feature of the cloud provider you can use. Then, since it's from the customer about the backup, the customer can choose only the retention period of the backup, since the platform will automatically do a daily backup. And if you want, you can enable Volo snapshot. Otherwise, the default is the object storage backup mode. So the customer could choose to do not enable the Volo snapshot. And yeah, next slide, please. So, and also just a screenshot of the platform where you can restore, so create a cluster by restore from an existing cluster. So this is just the mode when you can use the, or just starting from a deleted cluster also. And next slide. And we use this platform just for some benchmarking. So we compare some operation by using the default object store backup mode and the Volo snapshot mode. So what we have done is to simply create an empty cluster, then populate with some data, take the backup, and then try to create a new database by restoring starting from that, and then add more data and taking a second backup. So we want to see if the customer will have a real improvement while restoring a backup with the Volo snapshot feature, and also when the customer take a new backup starting from an existing one. So we want to be sure we have the incremental backup, incremental mode of the snapshot. So in the next slide, we will see the result from restoring from an existing cluster, comparing the object store and the Volo snapshot. And we have a great improvement, and it's working well on the various scenario, and for all the provider we test it. So from a customer point of view, we have a good improvement since the customer can start using the new Postgres cluster very quick regarding the object store method. Next slide, please. And the second metrics is about the backup time when we just add few data on a big backup we have. And for most, okay, since the object store backup method need to redo the whole backup, Volo snapshot just store the incremental part of the data, and we have a good improvement for all the scenario except for AWS, and mostly because when we watch the operation in progress, we see the Volo snapshot of the backup go very fast in the finalizing state, but before going in the ready state take a lot of time. And we think is most about an implementation detail for AWS, since the other provider go very fast in the ready to use state. So I think it's just about some details in the implementation for AWS. But yeah, the backup time is not something that the customer could see directly because it's done under the hood. But yeah, just to verify this, we made this benchmarking. And yeah, I think is all for the benchmarking. Yeah.
Okay, I have a question. So, so you said this is a Postgres for the AI generation. So, let's say if a customer use this platform for some AI workloads to do some training. Let's say because training takes a long time, right? Let's say they did backup periodically, but in the middle of the training, let's say they did 50% and then something happened, then they will have to rebuild it, and they want to be able to pick up from where they failed. Is that possible for them just to restore and then they will just resume the training? Is that possible?
I don't think I fully got the question here.
So I guess my question was just like, let's say if maybe you can explain more like how customer use this for the AI workloads. Like maybe that would be a better way to ask the
Yeah,
question.
I don't think this call will have anyone with the right expertise on the AI part of
Oh,
the
okay.
Yeah, I can.
platform.
I'm not an expert too, but
Yeah.
I can just share what
Yeah,
I know.
okay, Leo, go ahead.
So let's say the data type storage of Postgres is extendable. So you are not just limited to the types you already have defined in your database. And there are extensions such as pgvector that allows you to store vectors inside the database.
Mhm.
And not only that, but to even add more operator implementations that are usually, let's say, needed for this kind of workload, such as the cosine distance, all the, the data access structures of vectors. But so you can use your database to store vectors. You can use your database to store what is needed for training. But in my knowledge, the training itself, it is not hosted on Postgres, which is designed to be really fast and consistent in loading and storing and looking for data, but not running a bunch of maths against them. But this is just my limited knowledge.
Okay.
They are handled in different applications which use Postgres as a data store.
Okay. So the PostgreSQL, they use this more, they want to persist for a longer time, but maybe the training, those are more, they need it just for the period of training, but they probably don't need to persist it. So
Yeah.
they may not use PostgreSQL. Okay, yeah, makes sense.
Yeah, but there's also a team. Basically, I think most of us are specialized primarily on transactional databases and warehouses. For example, pgvector can be installed in cloud native PG based database. Yeah, but our expertise is primarily ends up there. Okay, so there's a team, separate team within EDB that is entirely focused on the AI stuff, and I know that they use Parquet as well. That rely on object stores to store this kind of data, and they use primarily Postgres databases as sources of data and where to run queries on the vector databases. But yeah, as the guys were saying, that's not our expertise. Okay, so it's already difficult to be experts in Postgres. So let's say that all we do is to enable running Postgres as a platform in Kubernetes. Then, for example, vectors are pgvector is an extension like Timescale or PostGIS. For cloud native PG, they're all the same. Okay, then you can use, depending on the use case, maybe you can leverage the storage differently based on the workload. Okay, but yeah.
Okay,
So
yeah,
yeah,
makes sense.
thanks
Thank
for
you.
the question.
Are there other questions for the team?
I just want to make sure I was getting your metrics right. So that first object store backup of a database with 150 gigabytes per second, or 150 gigabytes. If I'm trying to figure out throughput, that was when I do 150 divided by 30 minutes, roughly, I get just around 800 megabytes or 80 megabytes a second. Is that really the throughput that was happening there, or was there something that seemed low? I guess I was trying to figure out where the time was, or was that constrained behind some networking limitation?
Yeah, the time here was the time the backup, the time for taking the backup. So also for store data in the object store or in the on the vol snapshot to say that the data is safe. So
Yeah, I was just trying to figure out where if you were to give me a rough guesstimate of, is it a storage throughput problem on the object store side that's limiting it? Is it a network problem, or is it the action of taking the database and it's computationally heavy to create the image?
yeah, for the incremental backup, since the object store need to redo all the backup starting from the beginning, instead vol snapshot doing the incremental backup. So copy only the delta of the new data stored after the. This is for the incremental backup metrics. For the restoration part, is just because we start the snapshot is able to create the disk very quickly instead of copy the data from the object storage.
Let me try one more time on the question. If I wanted to cut that time in half, what would I need to provision to do it? More CPU, more networking, or higher bandwidth object store backend?
Hey, I'm taking a guess. I think this is probably just has to do with network. So if you have to upload
Yeah,
to the cloud, that is just very slow.
yeah,
You know, backup restore, both sides are slow, upload, download.
yeah, yeah. In my opinion, network latency is what is happening here with object stores. It is limiting us. This happens in the cloud.
Right, so you're using the object store API like S3 APIs or the Azure object store APIs, right? To do upload and download. So
Yeah, in my opinion, network latency has an high impact here with object store, yes.
All right, thank you.
yeah, but interestingly, I was thinking when you do snapshot, right? You do even though you do CSS snapshot for the cloud, they actually also have a upload phase. Yeah, I'm not sure why that is faster.
Yes, exactly. I think if you, Gabriele, just go back to the times. I think what happens with AWS is just that. We are seeing here in the volume snapshot column, we are seeing here the time that is taken to upload the initial volume snapshot to secondary storage.
Yeah. And you checked the ready to use is true, right?
Exactly. This is
Yeah.
the definition of this step.
So yeah,
It's
so,
the time needed to cut the snapshot.
mhm. Yeah, so the cut is quick, but I mean
Exactly. Yeah.
I'm not sure. It's the technology is a little different than if you are using a, let's say, S3 API to upload. It looks like it's different from if they are doing this internally. They cut snapshot and then they still have to do this upload. Still supposed to be slow, but it's not the same speed as if you are using directly using a S3 API. So
Yeah. I
okay.
guess that's what's happening there.
Yeah.
Because we are not classifying a backup as completed
Mhm.
until the ready-to-use flag is set to true.
Yeah, that means it's already done. Yeah.
Internally, from the database point of view, the backup ends as soon as the snapshot has been cut. But to declare that backup completed, we need it to be restorable. And to do that, we need the ready-to-use flag.
Yeah. Hey, sorry, we are at the top of the hour. Yeah, this is a great presentation. Thank you very much.
Thank you.
Thank you.
Alright.
Thank you.
Thanks.
Hey, can you please make that slides publicly accessible? Then we can add that to the agenda doc. Thank you.
Yeah.
Right.
Okay.
Bye.
Thank you.
Hi.
Bye-bye.
Goodbye.
Bye.
Bye.